Hi, this is Professor Serge Lassert. Here we are going into assignment 3, which I think is the most difficult of the assignment series, yet the most exciting. In this short video, we will review where we are in the DMAIC problem-solving methodology, as well as the concepts behind the science of improvement, followed by the expectations of assignment 3. We have completed the first 3 phases of the DMAIC problem-solving methodology. From the results of the analyze phase, you have gathered ideas as to potential changes that can be made that will result in an improvement. Assignment 3 is the improve phase, and it is about testing those changes. Now, in the real world, you would most likely test more than one change. However, in order to keep the scope to a manageable level in this course, you only need to test a single change. For this assignment, select a change you want to test and construct an hypothesis to test via an experiment. Draw conclusions from the results of the experiment and determine if the results align with the hypothesis. If so, then the change is adopted and communicated to the stakeholders for implementation. In effect, you are going through a plan, do, study, and act cycle. Keep in mind that in real life tests are not always successful. What is an hypothesis? It is an educated guess about how things work. Note the form of the statement of the hypothesis. It includes a statement about what to test and a prediction. An important element is the theory of change. It is an explanation that describes why you think a particular change will work. And finally, measurements are captured. A measurement about what is changed and the overall outcome of the change on the entire process. This is the SMART goal statement that you have developed from assignment 1. An example of a theory of change is this 5-step process where cycle time is the metric of concern. Let's say that a potential change is to perform steps 2 and 3 in parallel instead of serial. The prediction is that running process steps in parallel will reduce cycle time. An explanation of why you think that works is the theory of change. A new measure of cycle time of the combined steps is compared to the baseline as well as the impact of the change on the overall project goal. It is important to note that process restructuring often results in improved performance. The assignment 3 template is a PDSA cycle document. You plan what you want to accomplish with the experiment. Note that this is for the experiment only and not for the entire project. What is the difference then between a PDSA cycle and a Kaizen event? The Japanese word Kaizen means change for better. It is a philosophy of continuous improvement, whereas a PDSA cycle is a problem-solving method. The objective behind using PDSA cycle is to add rigor to problem solving. Here is a real-life application. Let's say, for example, that a healthcare organization has an improvement initiative to increase patient flow. In other words, reduce wait times. Indeed, that would be a large project. After the analysis phase, 3 changes are identified. A small-scale test is done for the first change in one hospital unit, if you will, the medical or surgical unit, for example. This test is then followed up with a few more units in the hospital and finally undergoes wide-scale testing. Alternatively, the second and third changes also go through the same process. The final implementation can include all 3 changes, which now have been thoroughly tested. In conclusion, in assignment 3, you construct an hypothesis about the potential change and you make a prediction about what you expect to happen. A theory of change explains why you think this change will work. And finally, you measure the results of your test. The final outcome is to state if you want to adopt the proposed change or reject it. This is how a PDSA cycle is used in the science of improvement. As a final comment, unless you use this process, one might as well use luck and hope as their strategy for improvement.